Hi guys, so here we're going to talk about what neutralization is in terms of acid and base reactions. You'll need your notes, your calculator, and table T. So neutralization reactions is when we take a strong acid and a strong base, and that solution becomes neutral, meaning that you have the same H plus concentration as you do OH minus concentration. So the H plus concentration is equal to the OH minus concentration, and that's at a pH of 7, just like water. So really what it means is that the moles of acid is equal to the moles of base. And when you put them together, you end up with water. So again, that acid and that base produces water. A byproduct is a salt, and a salt, to remind you, is any ionic compound, not just NaCl. So again, any ionic compound would be that salt. So to go through, when you have a strong acid reacting with a strong base, again, you have a pH of 7, the moles of the acid is equal to the moles of the base. You can use this equation. When you have a weak acid and a strong base, that pH is actually going to be greater than 7. So essentially that base wins out. It's going to be more in the basic range. If you have a strong acid and a weak base, it actually ends up being, the neutral point ends up being a little bit less than 7. So again, we want to figure out where the H plus concentration will equal the OH minus concentration. And so for a strong acid and weak base, that will end up being less than 7 in the acidic range. So here we have two examples. We'll do the first one, HCl plus NaOH. So we know that HCl can break up into H plus and Cl minus. NaOH can break up into Na plus and OH minus. So from here we're going to take the H and the OH and produce water. So HOH or H2O, and we'll take a look at what's left over. We have Cl and Na. We know in all ionic compounds that the metal goes first, so it's NaCl. So this is one example of a neutralization reaction. We have hydrochloric acid plus sodium hydroxide produces water and salt, or a salt, which is sodium chloride. So let's take a look at the second example. We have HNO3, so we know we have H plus and NO3 minus. We also have Mg plus 2 and OH minus. Remember that plus 2 is because that 2 really goes up there in terms of charges. So we want to eliminate the water. We want to combine the water, so we have HOH, and then we'll put together whatever's left over. So we have the NO3 minus and the Mg plus 2. The positive ion, the cation, always goes first. So we have Mg combined with NO3, so we have MgNO3 2. All right? And let's not forget to balance this as well. So I'm going to eliminate some stuff that we don't need right here. And we don't need any of the stuff down at the bottom to balance it, but we want to make sure that we do know how to balance this, so go ahead and give this a shot. All right? When we balance this, we end up getting 2 HNO3s and 2 waters at the end. Alright, so again, to summarize, a neutralization reaction involves an acid and a base producing any sort of ionic compound and water. Have a good day, guys.